Okay, we'll find the derivative for ln of x over y that's equal to e to the xy. And we see that the y is not isolated, and I don't think we can isolate the y. But it's okay, because we can just use implicit differentiation. However though, before we do that, we see we have x over y inside of the ln. So, by one of the ln property, let's rewrite this as ln of the top, so that's ln x, and then minus ln of the bottom, which is ln y, like that. And then this is still equal to e to the x times y, like this. So this way we don't have to use the quotient rule, right? All right, from here we can go ahead and I will just write down dx to represent that we are taking the derivative with respect to x. And here we go. The derivative of ln x with respect to x is 1 over x. And that's it. You don't really need to multiply by the derivative of x with respect to x, because that's just equal to 1. Anyway, continue. You minus, and the derivative of ln y is 1 over the inside, which is y. But the chain rule says we have to multiply by the derivative inside. Derivative of y with respect to x, that's dy dx. And this is how we squeeze out the dy dx. Earlier, if you put down dx over dx, that's 1. But here we have the dy dx. This is what we need, right? So this is it for the left-hand side. And now, on the right-hand side, we have to differentiate e to the x times y. So first, remember that derivative of e to the something, it always repeats first. So let me write down e to that thing, namely x times y. And now we have to remember the chain rule, we have to multiply by the derivative of this. Well, derivative of x times y, it requires the product rule. So let me multiply, and I will open the parentheses, product rule in action. I will first keep the first function, namely x. And then we multiply by the derivative of the second, derivative of y with respect to x, that's the dy dx business. And then we add it with the second function, which is y, and then multiply by the derivative of the first. Derivative of x with respect to x is just 1. So this is what we have, and this is the calculus step. And then for the rest, we are going to isolate the dy dx, right? And the usual deal is we will collect the terms that have dy dx on one side first, and then just isolate that from there. Before we do anything, let's go ahead and distribute the e to the xy into here. So let's see, here we will have 1 over x minus 1 over y, and this is the dy dx. And this is going to be, let me put down the x first, and then e to the xy, and then the dy dx. And then we have this times that, which is just plus y times e to the xy, like this. And now, these two terms have the dy dx. Let me bring this to the right-hand side so that I can deal with everything with positive, right? And then I'll bring this to the other side. So perhaps I will show you guys the work. I will write down plus 1 over y dy dx, and then we'll say plus 1 over y dy dx here. And you see this and that will cancel. That's good. And then I'm going to minus y e to the xy, and then I'll put it down right here. Minus y e to the xy. So that this and that will be cancelled. That's good. Okay, now let me actually write down this part first on the left-hand side. When I have this plus that, I will factor out the dy dx and put it at the end of the parentheses. So I will write down x e to the xy plus 1 over y, and then we have the dy dx. And this will be equal to 1 over x minus y e to the xy, like that. So this is what we have. And to isolate dy dx, we can just divide both sides by this. So I will just do that right here for you guys. We will see dy dx is this on the top, namely 1 over x minus y e to the xy, and then this is all over that. And let me just write down the 1 over y first because that lines out this nicely, right? So 1 over y plus x e to the xy, right? So that's pretty cool. However, here we have a complex fraction. Let's go ahead and multiply the top and bottom by the least common denominator of the small fractions. We see that we have an x here and we have a y here. So let's go ahead, multiply xy, xy, xy. So in the end, we see that dy dx is equal to, when you multiply this and that, the x cancel out, so we have just the y left. And then we have the minus xy times y, so we get x. And then y and y, you multiply them, you get y squared, and you have e to the xy power, and then this is all over. So I forgot to draw the arrow, but it's okay. Anyway, take this times that, the y cancel out, so we have x. This times that, it's plus, x times x is x squared, and then we have the y, and then we have e to the xy. So this right here is it. This is the answer. That's it.